Wow! Hello, my dear friends. You are welcome to Joe Newton online class. It is time for us to learn physics. Yes, look at the task on the board. This is taken from the topic of principle of moment, that is under equilibrium of bodies. Of course, uh, some time ago, I taught us here the concept of equilibrium of forces, the condition of equilibrium, and the terms principle of moment there. Even the every other time there. When you go to our YouTube channel, our Jonathan online class, in the playlist there, you see them all. Then we have this task. Of course, this is a solution to be provided for the task already published on Jonathan online class Facebook page. Now, look at this. We are given, we are asked to determine the magnitude of the force P in the diagram below. Looking at this diagram, you can see that we have a pivot here, we have a force, a body here of weight 40 Newton, then we have a force P here, inclined at an angle of 30 degrees to the horizontal, and this system of forces here, keep this body in equilibrium. So for this body to be in a state of equilibrium, we shall remember the principle of moment, which says that the algebraic sum of the moment of forces about the point should be equal to 0, or that the total upward forces will be equal to total downward forces about the point. Or, in other words, that the sum of the clockwise moment of forces about the point should be equal to the sum of the anti-clockwise moment of forces about the same point. Now, looking at these conditions, let's look at this diagram. It appears to be difficult. It is not difficult, but just only technical. Good. Now, in solution, we observe, first of all, this force P is not perpendicular to the point here, the pivot. So we have to resolve this point P, the resultant force P. We have to resolve to find the perpendicular component, that is the vertical component of the force P, with respect to this word pivot. So we have to resolve this first by resolution of vector. We should know, of course, that force is a vector. We have to resolve it to get the perpendicular, that is the perpendicular component, that is the vertical component of this force, which is the perpendicular. So it will be perpendicular to the force, because we say that moment of a force is the product of a force and the perpendicular distance from its line of action to that point. Good. So doing that here, look at this. We have this. We have this. So let me use this here now. So let's call here Py, that is the perpendicular component of this P. Then from here to here, of course, this is the distance to the pivot, which is this plus this, which will give us what? 50 centimeter. That is from here to here, from here to here. So this is the perpendicular component of the force. Now, what do we do now? This is the resultant force P. This is Py. Now, taking the resolution here, we should know that if we have something like this, this is what we have, P, and here is Py, here 30 degrees. Now, taking it from here, from what we have there, we should know that this Py should be equal to P sine 30 degrees. That is it. So by resolution of vector, this Py is equal to P, the resultant force, sine 30 degrees. Very simple, by your primary knowledge of SOHCAHTOA in mathematics. Good. So having known this, let's take note of this now. We now come to this body. Coming to this body now, we are now to find this is, of course, this arrow shows the anti-clockwise moment. Then this weight of 40 Newton should act this way as the clockwise moment. So this is the analysis we need to do there. So taking moment about C, point C, the pivot. Let me call the pivot C here. Let us label the pivot C. Taking moment about C, we should know we are concerned with this force Py, which is perpendicular to this plane. Force Py times the distance from the pivot is equal to the force due to the weight of this 40 Newton times the distance from the pivot. So this is the pivot. This is the pivot. So that is it. So in that case now, we shall now have, so this is the pivot. So what we shall have now is Py times 50 cm times 50, that this distance from here, which is 30 plus 20, is equal to 40 times 20. The 40 here, this is the weight, the force here, downward force. This is the upward force. So this downward force here times the distance from the pivot from here to here is 20 cm. Then that will give us, now substitute this value. When we substitute this value, recall that this is our Py. This is our Py. So when we substitute this value now, we now have, therefore, it becomes P sine 30 degrees times 50 is equal to 40 times 20 is what? 800. That is substitution because Py is equal to P sine 30. And we're interested in getting what? This P. But this is the component we resolved to solve using the principle of moment. Because we cannot use this to work on the moment. Because for moment of a force, it has to do with the perpendicular force and the distance from the pivot. So having this will give us sine 30 degrees is 1/2, which is 0.5. So we now have P times 0.5 times 50 is equal to 800. And of course, we know that 0.5 is half, so half times 50 will give us what? 25. So that will give us P times 25 is equal to 800. Remember that 0.5 is the same as 1/2. Okay, so that will give us P is equal to 800 all over 25, which will be equal to, of course, 5 divided 25 will give us 5, and 5 divided 80 is what? 16. 5 divided 0, that will have 160, and that will give us finally 5 divided itself 1, 5 divided 15, we get 3. Remember 10, put 1 here, that is 10. 5 divided 10 is what? 2, that is 32. So our force P is equal to 32 Newton. So the force P here should be 32 Newton to keep this system in state of what? Equilibrium, balancing it with this force and taking the moment about the point where the pivot word C as required in the diagram or in the question. Thank you so much. I believe with this you have learned or understood how to tackle similar problem involving what? Principle of what? Moment, where you have maybe non-parallel coplanar forces or parallel coplanar forces. In subsequent times, we shall deal with other several cases where we have non-parallel coplanar forces, where we use triangle of forces to resolve. Thank you for paying attention to this. For more of these solutions and concepts in physics and mathematics, visit my YouTube channel at Joe Newton Online Class. Also follow me on Facebook page at the YouTube there. Subscribe, share, and comment. Drop your questions there. Subscription is free. Thank you so much. Join me on TikTok.